Test.
Mike. Can you check mics?
Test.
Check, check, 1, 2.
Kohut. Hello and welcome everybody to Udacity's first robotics Q&A with one of our industry professionals. I'm here with Nick Kohut from Dash Robotics.
Yep.
Also make the product now called Kamigami Robotics. Nick, how are you?
Good, how are you?
Doing well, thank you. Thank you very much for joining us today.
Yeah.
So can you tell me a little bit about Dash Robotics and kind of what you do?
Yeah, sure. So we started the company in 2013. My co-founder, Andrew Gillies, and I, we were grad students at UC Berkeley. Mm-hmm. And we'd always wanted to start a company. Didn't really know what we wanted to do. We were working on insect-like robots. Actually, it was originally for the military. They were using them for recon and things like that, so I'd present every year in Maryland for them. And so that's what I was working on in graduate school and wanted to start a company, but didn't really put the two together until we did some outreach events where we brought the robots to schools and museums and just showed people, oh, this is what we do for research. And kids were like playing with the robots and just going nuts for them. And the parents were like asking them, asking us like, oh, can we buy these? And finally we're like, well, maybe this is the business, Mm-hmm. So we started out building some earlier generations of these robots and selling them to consumers through crowdfunding, through Amazon, through stores. And that was going pretty well, but what we really found out was that our strength was in the engineering and product development, and all that distribution, marketing, supply chain stuff. There were other people that were great at that already knew how to do it.
Sure.
And so what we do now is we actually work with large companies and large brands, partner with them. We handle a lot of the higher tech engineering side, mm-hmm. and they handle all the distribution. So for example, this Kamigami Robots project is being licensed to Mattel starting for this Christmas season in 2017.
Oh, very cool.
Yeah. So that's been really exciting for us. And so we're working with them to bring the product to market.
So this is going to be available pretty much all over.
Yeah.
I mean, Mattel's got a pretty wide reach, right?
Yeah, they know how to do that
That's
part for
very
sure.
So you said that you went to Berkeley and you studied at Berkeley, and you're your co-founder as well, right?
Yeah.
And you ended up doing some insect robots for the military. This is kind of how this started. What's your background actually? What were you studying at Berkeley?
Yeah, so I got my undergrad at University of Illinois, Urbana-Champaign, doing mechanical engineering. I was mostly into automotive stuff at the time. I went to Berkeley for grad school, got my master's in control systems, still working in the automotive space, doing some work for Audi. And then that was around 2008, 2009.
Okay.
And there was the big financial crash.
Yes, very familiar with that.
Yeah, I think a lot of people are very familiar with that. And like the funding for a ton of projects just all dried up at once. And so I thought, I need a new project. So I'd actually never done robotics before like 2009.
Okay.
I was, like 25 years old. I joined this robotics lab. The government still had some money. So like I learned how to solder and really got into robotics, fairly late in life. But, worked hard and tried to be a quick study and was, writing papers within a year on robotics.
Did you find the leap kind of hard to kind of jump? I mean, mechanical engineering background, so it sounds like most roboticists I typically end up talking to, a lot of them actually come from the electrical or the mechanical space. Was the jump pretty smooth for you, or did you have,
No, I think it's a hard jump. I think that robotics is a really broad field. It can be mechanical, electrical, computer science, even a few others. But yeah, no, it was tough. I had done a lot of like control system stuff, which is more, I guess you could say, like on the software side. And so then I was doing like hardware all of a sudden, which I hadn't done a lot of. I was more of like a math engineer than like a big tinkerer guy, and so I had to like learn how to do all that. But I don't know. I mean, I just kept practicing at it, and you get better and better. And after a few years, you're like, oh, I'm actually pretty good at this.
So it was something that you've crafted over a longer period of time.
Yeah.
It wasn't something that you immediately decided one day, like, hey, I'm just going to be a roboticist, and within a few weeks you were going to be up and running. You knew it was going to be kind of a long haul, and
yeah,
really
I would say
it
took like a semester of like spending some late nights at the lab and. Frankly, just like breaking things and be like, oh, I gotta start over and like do it again. And then you do that, enough times, then you get pretty good at it.
Yeah, eventually you stop breaking things.
Right.
Is the goal.
Well, you break more complicated things.
Yeah. Well, hopefully you build more than you break at some point,
right.
So talk to me about this bug in particular. So this is actually really cool looking. So I don't know if everybody on camera can actually see this, but this is actually really lightweight. It's it looks like it's pretty durable. Is that true? Or
yeah. So this guy is about 50 grams, about 1/10 of a pound. It is super durable. It's made of this composite of plastic and fabric. It's a patent-pending material that we invented. The original material was built in the lab at Berkeley. They were working on it for like 10 years. Started doing these really tiny, like fly-sized robots.
Okay.
And scaled them up to like palm size, and we took that process and brought it from like a prototyping process to a production process where there's thousands of these things, and we can build them scalably. So yeah, it's got I don't know. My guess is around 50 or 60 joints. It's all in one sheet. So this is the box that the product comes in today. All this is getting revamped for the new release, and then you have a sheet here that makes up the shell. So this is a ladybug shell. This is like we call it like Kamigami stealth shell. It's just a fun design. But you can put all kinds of different shells on the same base. And then the base is this flat sheet of, like I said, this composite of plastic and fabric that you punch out the pieces and then you fold up yourself. And then there's instructions on the app. Takes average 8-year-old about 45 minutes.
Okay, so is there any soldering involved in this kit? I know personally I'm a lousy solderer.
Right.
I can't do it. Save my life.
There's no soldering. There's no tools required. So it comes with electronics and a motor, a couple motors and a gearbox, and then it's got these push rivets. So you just like push these through.
Oh, very nice.
Yeah, the holes in here. So there's no tools or anything. Which is actually one of the hardest parts of this whole design.
Right.
Because originally these types of robots took like an hour for a trained graduate student to build with special tools. And we had like dentist tools and things like that. And then we were like, oh, we'll just have 8-year-olds build it for us. That'll be a good idea. And that was actually the hardest part of the design, but it really paid off because like the kids really love to build it, and then they also feel a connection to the product once they've built it. It's like a toy that they've invested something into, so they're not just going to like play with it for 2 seconds and throw it away.
You build it and play with it, you kind of see it come to life.
Yeah.
So one of the things I really like about this is this flat design. What was some of the inspiration for doing something like this as opposed to something that was kind of 3D printed or maybe molded? and kind of showing, that kind of a shell to put together versus having something that's all kind of flat.
Yeah, so the original process was invented to develop robots that were the size of like a small insect, like a fly. And at scales like that, you just can't get traditional joints to work. There's too much friction. I mean, if you had a ball bearing, for a joint that small, it just would not work.
Right.
So this is a way. So all these joints are essentially frictionless. They're flexure joints, kind of like living hinges, but they basically never fatigue. They're ripstop nylon. And so it also allows you to build these really intricate mechanisms. So this guy is like, I would say like simple but clever.
Right.
So I mean, there's only 2 motors, but he's a real running robot. Like, he's not vibrating; he's actually running just like a real animal.
Interesting.
So we're able to like pack this complex mechanism into this like tiny space because of the construction method. So that's
Very
pretty key.
cool.
Yeah.
Very cool.
Yeah.
So talking about a little bit about the running mechanism, how long did it take you to kind of study that and break down that process of, obviously it's biologically inspired, right?
Right.
So what was your process for kind of going through that, if you wouldn't mind sharing something, something of that nature?
So a lot of that comes from the research at Berkeley and a few other institutions. I think it was Professor Bob Full is a biologist there. He discovered a lot of the early principles of animal running like back in the late 80s, I want to say, like 89 or something. And they started applying it to robots ever since then. So I, joined Ron Fearing's lab at Berkeley in 2010 or so. So at that point, they've been working on it for, 20 years or something. Sure. And so they've been baking into a bunch of robots. I'm sure you've seen like Boston Dynamics stuff.
Yeah, I've seen their big, like,
a lot of that comes,
thing,
a
right?
lot of that comes from the same principles. Like totally different robot. Like, I don't know how much this costs, probably $1 million plus, and this is like $50, But a lot of the same sort of bio-inspired principles are packed into this robot. And so we look at the gait of the robot, like the pattern in which the legs move, also the stiffness of the legs and the overall system relative to the mass of the system is super important. And if you like tune those 2 things correctly, then you generally get this like really fast, efficient running.
Interesting.
Yeah.
So did you do a lot of simulation, or was it more trial and error to kind of?
It's mostly trial and error. We did a bit of modeling. A lot of it is experience building these kind of machines. They're kind of a unique thing. There's like, I don't know, maybe 30 or 40 people who build these in the world, and we're 4 or 5 of them.
Sure.
And the only people doing it on a commercial scale. And so a lot of it is just trial and error, and then you start to develop an intuition around it and a skill set around it.
Interesting.
Yeah.
So can you talk to me about a little bit of some of the sensors that are maybe on board?
Sure. Yeah. So let's see. So there's a microcontroller on board, of course. It's Cortex M0 core, and then it's got Bluetooth Low Energy on it as well. As far as sensors goes, you've got 6-axis IMU, so that's 3-axis accelerometer, 3-axis gyroscope. Okay. So you know about the motion of the robot. There's a light sensor. So we have like a game Afraid of the Dark, where if it goes dark, the robot like flips out. Just to add a little personality. Sure. And then there's these 3 IR receivers and an IR emitter, which is 38 kilohertz encoded IR, which basically just means that it can send different messages. So you can build games in the apps that can know like, oh, I got hit from behind with message A, or I got hit from the right with message B, and you can have different reactions based on that.
Interesting. Very interesting.
Yeah.
So what were some of the challenges? Did you guys develop this board yourselves, or was this something that?
Yeah, we did.
So what were some of the challenges with like design and function? Was it weight a consideration?
So,
was it?
Yeah, I think this board is definitely well designed. We do try to keep the hardware like as close to commodity as we can. Again, not that there's not like clever design in here, but we try to keep it pretty straightforward because that keeps the cost down. Sure. And then we try to add as much replay value and intelligence through the mobile device itself, because this connects to a phone or tablet, Android or iOS. So this guy is really kind of like sending and receiving commands. It's just telling the phone like, oh, this is the sensor reading A, this is the sensor reading B, and it's just receiving commands, fire the motors with its power or whatever. And then most of the logic is done at the level of the phone or tablet.
Okay, so the phone does most of the controlling. The phone is basically the brain, if you will.
Yes,
right?
yes.
And this is more like a nervous system. Like
yeah, that's actually a great analogy, because
back and forth between the
we
two.
do some like steering control. So like when you press the joystick, it doesn't just fire the motors forward. It actually adjusts based on how the robot is moving. that has to be on the robot, because if you try to send messages back and forth between the phone and the robot, it wouldn't be fast enough.
Right.
So I think the nervous system is a great analogy, because it's that, like quick reaction, like when you touch a hot plate or something, like you immediately react. So you need that immediate reaction for some of the controls in the robot.
Now, is there any, so I can steer it from my phone, I can steer it from a tablet.
Yeah.
Does it work for Android and iOS? Or
Yes.
is it, okay, so it's compatible with both major platforms.
Yeah.
Is there an autonomous mode, actually, for the robot as well?
Yeah, it can do a little autonomy. It's not like some sort of like PR2 robot or anything that's super high autonomy, but most of the autonomy is around, it does some really basic odometry based on like the motor power. It guesses how far it's gone, and it knows its own orientation based on the IMU. So you can do things like drive in a circle. One thing I'd like to add is like react to music, which again, you would drive some of that autonomy through the phone. Like, you're not going to run that on this.
Definitely.
So it does have some limited autonomy. But for the most part, it's like a platform to play games. So it comes with like 9 games loaded onto it already, and then you can build your own too. There's like a simple programming interface based on like actions and reactions.
So is the program interface more like a drag and drop type of interface?
It's similar to
similar
drag
like
and
a
drop.
Scratch type of thing, maybe.
Yeah, it's like there's a UI around it where basically you pick triggers and actions. So a trigger might be like if the robot is in free fall, or if it is running, or if the lights go out. So there's various triggers, and then an action might be like it spins, or it lights up, or it makes a noise, or it increments a score. And then you can have triggers based around the score, like, oh, if the score goes over 3, game over, right? Something
Gotcha.
like that. Yeah.
Very cool. Is there any way to control multiple robots from the same phone? Is that something?
So that's technically possible, like it's part of the Bluetooth protocol, but we haven't implemented that at this point. Yeah,
So
it's one robot to one device right now.
Next release, right?
Yeah,
yeah.
yeah.
So can you talk a little bit about your kind of like day-to-day? What's your typical day kind of coming in? I understand you're a CEO and a co-founder, right? So it's there's a bunch of different hats that you're wearing, doing different things that are outside of the robotics realm, but like just even from when you were coming up and just kind of getting started, what was like your typical day-to-day type of actions for somebody just trying to get like off the ground, maybe doing something in the space?
Yeah, so I think there's definitely no typical day, of course, but there are a few key things, and what you do in the beginning and what you do later on are very different. So in the beginning, you're basically doing just everything, right? Like at the beginning, we built like 1,000 of these on our own.
Wow.
My co-founder hand-assembled all of the gearboxes, like all 1,000 of the gearboxes. I laser cut half the units. We drove every single unit to the
And it was
post
just
office.
the two of you at that time?
It was the two of us, and we had one of our friends and now our first employee, Dwight Springthorpe, was with us as well. He was doing like kind of nights and weekends with us. So yeah, for the most part, I mean, we had help, but like for the most part, it was like 2.5 people. So we did just everything. And then as you go along, you get more people. So my day-to-day now like kind of depends what phase we're in.
Sure.
So right now we're hiring. So that's like my main gig, I guess.
Okay.
Is like trying to recruit, reaching out to people, doing events, networking, talking to people I already know. You know anyone who's good. So yeah, we're looking for a great mechatronics engineer. So I'm going to do both mechanical and electrical. Robotics engineer who can do some more R&D stuff. It's like stuff 12 to 36 months out. And an Android developer as well. So I'm pretty focused on that right now. In the past, sometimes I'm really focused on fundraising. We've raised 2 rounds of funding in the past. So
Congratulations.
That's like, oh, thank you. Yeah, so that's like what I'm doing every day, trying to run down partnerships like this one we've done with Mattel. Setting strategy or like monthly goals or quarterly goals maybe. So it really depends day to day, but like those are the main tasks that I do. Yeah.
Can you talk a little bit about some of the positions? I know you mentioned that you have some positions open. Right?
Yeah.
So I know there's a lot of aspiring roboticists out there, people who are actually interested in working in robotics companies. What kind of things would they expect to do, kind of coming to work for you, or what kind of skills would you look for, or would you say are kind of ideal candidates?
Yeah. So we have a pretty small team right now. We have 7 people. We do a lot with our 7 people, which we're super proud of.
Yes.
Yeah.
Yes.
And so I guess I can just go through the roles one by one. So the mechatronics engineer is sort of on the front lines, probably in charge of like the entire mechanical and electrical of the whole product, which we have one of those guys right now. He's fantastic, but we want to do more.
Sure.
So we need someone equally awesome. So yeah, it's a combination of like design engineering, where you're really like coming up with mechanical and electrical designs from the ground up, to you're going to be talking eventually to like contract manufacturers in Asia, you know, about like how do we take this design and actually put it into something we can produce.
Sure.
Although we do try to skip some of the more rote DFM stuff,
right.
design for manufacturing. But yeah, that or like talking with our partners to know like what they want for the product, because you know we do develop products for other companies. So it's really a big mix of things. I think anyone who's been in that hardware startup environment before, that's like seen a product go from 0 to shipping, would definitely be an ideal candidate. And then for the robotics engineer, I think there's a lot. So we're in the toy space. And I think toys are fun because it's so creative. Like you can kind of do whatever you want. I mean, there's certain cost constraints, of course, but like it doesn't have to. It just has to be fun, right?
Sure. Yeah.
So, so I think the toy space is great, but I think have been a little slow to adopt a lot of the tech trends.
Right.
You know, I think video games took a lot of mind share away from toys. I think mobile games now are doing the same thing. And I think there's a lot of just like open field, untouched space for technology in the toy space, whether that's like indoor localization or computer vision or swarm robotics, you know, sensor algorithms. There's just so many things that we want to do that maybe we've dabbled with in grad school, but like we don't have time to do it. And I'd really love to bring someone on who can look ahead a little bit.
Sure.
Likely has a master's or a PhD. I think you know, like frontline experience is not as necessary for this one because it's more research based. But you know, also someone who's worked in industry for a while is always great too. So that would be the robotics position essentially. And then the Android dev is, I guess, fairly straightforward. So we build apps, iOS and Android. Sure. We have iOS in-house. We've contracted out the Android. We'd really like to bring that expertise into house. I think it's important. You know, bonus points for experience with Bluetooth and hardware, but that's not necessarily necessary.
Sure.
Bonus points if you're into like game design or gaming, or maybe you've done a little Unity. But overall, looking for like a really solid Android dev who can build awesome apps, both for this product and for future products. And we are trying to build things as much as we can as a platform and make them reusable and scalable.
Definitely.
Yeah.
So a lot of our students actually have a lot of the skills that you're looking for.
That's great.
A lot of them are iOS developers, Android developers.
Oh, cool.
We have computer vision people in our programs.
That's awesome. Yeah.
So you know, if you're interested, you might want to reach out to Nick at some point. Hopefully.
Yeah.
What's the best way for them to reach you for contact information?
You can just email me, nick@dashrobotics.com, Nick. Yeah.
Perfect.
Yeah.
So one last question before we start taking questions from our viewers. What are some of the difficulties that you see kind of day to day, and how do you want to see robotics kind of progress?
Those feel like two very different questions.
Well, at least for your company, let's say. Let's rein it in a little bit, I guess, right?
Yeah. So I think
so your day-to-day challenges and how you'd like to see things kind of progress.
Yeah, I think day-to-day, I mean, the reason hiring is like my number one priority is because we have so much work, right?
There's a lot of cool things you can do.
A good problem to have.
It's
like,
always a good problem to have.
A lot we want to do. So that's our biggest pressing need right now is we just need, you know, more great engineers, more great people to work with us. As far as where we want robotics to go, again, that's a big question, and I think right when I was getting my PhD was probably my best time to answer that. But I can talk a lot to it with the toy space,
right?
Because I just think there's so much opportunity for bringing a lot of replay value into toys. I think too often toys get played with for, you know, if you're really lucky, it's like 2 weeks, and then people forget about it forever.
Most of them are one-dimensional style toys.
Yeah,
right?
They're pretty one-dimensional, and the ability to bring software onto a hardware product, I think, just adds a ton of potential for replay value. And also, we do back-end analytics on the units to know like what people are doing with them.
Interesting.
We don't know who is using them,
right?
Because we're very sensitive about like child privacy protection and all that. So we have no idea who is using them for what. But we do know like, okay, in general, like people really like this feature of the robot. They don't like this one. Like, how can we improve it? And I think that can really be big for the toy space because I think this revolutionized the mobile game space about 10 years ago or so when they brought analytics into it. And I think you could do the same thing with toy hardware, whereas the toy industry, you know, until now has really been what does the packaging look like? What is the price? Because that's all they see, right? Once it leaves the store, it's gone, right? But, I mean, everyone's putting, reviews on Amazon. It's been around for a long time now. I mean, word of mouth is like lightning fast. And if you can understand like what makes a great toy, from data, that's really powerful. So.
Definitely. I think this is a great platform. I think one of the things that's really interesting about this is it's a toy that kind of grows with your age a little bit too.
Yeah.
So whereas you're maybe a typical 8-year-old, you've assembled it, you really don't quite understand how to program it yet, but you can play around and you can have fun.
Yeah.
But as you get a little bit older, maybe 10, 11, 12, you start coding a little bit maybe, and you
Right.
start playing around with the drag and drop interface.
Yep.
You start allowing, you breathe new life into something.
Yeah.
Which has been around for a while.
Yeah.
So is there anywhere that we can go right now to kind of pick these up in stores? Are these available in stores yet? Or are they available only online? Or
Yeah, so we're kind of finishing off this run of product.
Sure.
It is still on Amazon. So if you search Kamigami Robots on Amazon. Also, we have a product website, kamigamirobots.com. You can find them there as well.
And I'll make sure to add both of those links for you in our Slack community as well. So, Nick, let's go ahead and shift gears a little bit and take some questions from some of our folks that are watching. So let me start off with one of our students, Andrew Wilkie. Hi, Nick. Congratulations. Really nice product design. What were your biggest challenges from getting from idea to final product?
Yeah, that's a good question. I think in the beginning, a lot of it is just, I mean, for me, I was like pretty much a total novice when I started this whole journey in 2013. So a lot of it was getting the resources we needed to do it. And, we got lucky a couple times, and we were really fortunate. So we got some space to work in, both first at Berkeley on campus. We were part of a campus accelerator, and they gave us lab space and meeting space, which was great. We had an advisor who had some extra space in Sunnyvale, and he gave us space and access to a laser cutter. So getting those resources was really critical. And I think also just like constraining the design and keep hammering on it until it actually, actually works, and doing a lot of testing. And we did a lot of user feedback. I think that was super important. We tested with like 500 kids before ever shipping. So, I mean, it's a whole lot of things.
Right.
Yeah,
Definitely agree with you. Yeah, it's very interesting how multifaceted it really is to be a roboticist, and it's not, you can be just good at one thing. You have to be good at a lot of things. You have to be great at a few of them, I think, in my personal opinion. So next question here is actually from Adam. Hello, Nick. Your robotic toys look great. What would you recommend for someone that, say, has graduated from the Udacity Robo Nanodegree, but doesn't have a traditional degree and would like to transition into a career of robotics? Thanks.
I think the most powerful thing there is going to be a project portfolio. Like if you can show people what you've built, it's not going to matter like where you went to school. If you've built some awesome stuff and you can show it off and like explain it and be knowledgeable about it, then people are going to want to hire you.
Yeah, this is one thing I think is the general trend pretty much everybody you talk to, right? Especially in the field of robotics.
Right.
It's like, oh, I'm taking these classes, and everyone's like, build.
Yeah.
Build. So luckily, our students who are actually going to be in our Robotics Nanodegree are actually going to work with hardware as part of the degree.
Oh, cool.
So that's actually being shipped with
great.
part of their work experience.
Yeah.
So,
and you can build software too, right?
Yes.
Like
so they're going to get the whole suite. They're going to have some computer vision background too, just in case you're still looking for some people.
Great.
So let me get to the next question.
Sure.
Hello, Nick. I really like to join your robotics team someday. What is the typical hiring process for the robotics engineering position, particularly in your company? I have never been through such, that's why I'm asking. What should one do to prepare for a robotics job interview? This is a very good question.
That is a really good question, yeah. So our interview process, we try to keep pretty straightforward. We try to move pretty quickly. That's one of our advantages over like a large company. So what we'll do is we'll either screen for people or do job postings and just put them up on various sites, with the job description, and then you just email jobs@dashrobotics.com, which right now just goes directly to me. And I'll basically take a look at your resume, cover letter. If people have a portfolio, that's like an extra bonus. And then if someone looks like they have the relevant experience, I'll just reach out to them and say, hey, let's do a phone interview. That usually takes 15 to 30 minutes. And that's the way we do it. It's usually non-technical.
Okay.
It's really just like, what do you want? What do you want to do? Like, what do you want in a role?
Culture fit type of role.
Yeah. And what have you done? And I might ask a few questions about like, what projects have you done? Can you tell me about them? Oh, why did you do it that way? Things like that. It's just at a conversational level. And then if that goes well, we bring people in for an in-person interview,
Mm-hmm.
and that's a little longer. That's usually that can be like 4 hours easily.
Okay.
And so we'll do another kind of like more culture interview, and sort of this soft technical. We're just asking you about your projects and like explain a project to
Sure.
us and everything. We'll grab lunch. I think that's important
Mm-hmm.
to eat with people, and then we'll do like a technical interview where we're asking you some whiteboard questions, but a lot just like digging deeper on like what you've done and why you did it and why you made those choices. Because for some of this, mechatronic stuff, it's not like software where you can necessarily be like, write the sort algorithm.
Sure.
You're not going to be able to be like, build a robot in the next hour.
Hour and a half.
So a lot of it is just more like drilling deeper on what you've done. So I think if you have a project to show off, that's great, and like be able to really explain it like inside and out.
Sure. Have them bring in their projects. Is that something that you like?
If you can, yeah. I mean, that depends on the project, right?
Right.
We had an intern who did a thing where like you like play a keyboard, and then there's like this cylinder, and then flames that go up based on what you play, and like so he didn't bring that in,
Yeah, that's
which is probably good because we
yeah,
didn't burn the
probably
building
fire
down or
hazard,
anything.
right?
But it was a pretty cool video, and he was able to explain his design and everything. And
That's
so
a really
he
cool
worked
thing to
out
see.
great. Yeah.
Yeah, very cool.
Yeah.
So this next one is from Suman. Hi Nick, love your idea and your product. I have an idea of developing something and confident in being able to write the software components after a course completing the Robotics Nanodegree Program.
Mm-hmm.
Are there any companies that can supply me with custom hardware? I also like to know your suggestions on how to proceed from idea to product.
Yeah, I mean, so as far as custom hardware goes, there's plenty of companies that, usually need cash, right? There are plenty of companies that basically are like engineering for hire,
Right.
that will do electronics development or robotics development. So
I believe Electric Movement is one of those people who does some custom hardware as well.
Oh, I haven't heard of them.
Yeah,
but
so they're one of our partners for the Nanodegree
Oh, okay.
program.
Very cool. Very cool. Yeah. So there's plenty of those. Also, I think if you can find a partner to help you, I think if this person's able to do the software, you can find maybe a partner who can do the hardware. That's a great like symbiotic relationship.
I'd also like to add that it's usually easier, like you said, to go with commercial off-the-shelf parts at first, right?
Yeah.
Make something even if it's big and clunky, and you can always work on shrinking it down as you kind of go through the process. Right?
Yeah. I mean, there's also the notion of like a works like prototype and a looks like prototype,
Right.
and you don't have to like smash those together at the beginning. There's a lot of great rapid prototyping tools now, whether it's laser cutters and 3D printers or like Arduino to quickly prototype firmware. And then there's a million things for prototyping software.
Sure. What types of
yeah.
languages would you use for your prototyping for your software typically?
Oh man! So for the mobile apps, we do that all that
Java
all
and
native
stuff,
right now.
Swift
Yeah.
and et cetera.
Yeah. And then for firmware, yeah, we'll definitely try stuff out on Arduino first. Usually, so we have an API on our firmware so that we can like quickly play with things.
Sure.
But for like newer stuff that's like farther away, it's easy to just like hook up an Arduino.
Perfect.
I mean, I'm not really like a software engineer. I was
Sure.
a control systems guy,
Right.
which is like MATLAB, which I think a lot of people might say it's not real software. Fine. But I picked up Arduino in like 2 hours.
Cool.
Like
Yeah.
I wrote a control system for this thing in like 2 hours, having never done Arduino before. So
Very cool.
it's definitely, yeah, you can pick it up.
Yeah, the processing language is actually a really nice language.
It is.
Right?
It's
It's
really
very
nice.
easy to kind of get up and running really quickly. I was really impressed with it.
Yeah.
So the next one is from V. Shankar. Apologize if I'm not pronouncing that correctly. So, hi Nick. I'm planning to work with a TAL robotic arm by Tata Bravo for my senior mechanical project. What can you suggest I should learn during this project to make me industry relevant? I'm learning kinematics and planning to learn image processing.
Yeah, so I think that robotic arms are like a really well-established field. So I think you're already doing the right thing by like working on that project. And I think that you'll learn a lot of those kinematics and inverse kinematics, and you'll learn how to program that arm. And like, I don't know. It's like he's already answered his question. That goes back to my point of like. So I think that theoretical underpinnings that you learn in school are important.
Right, the foundations are definitely
the foundations are definitely important, but that project work is where a lot of that kind of clicks, right? And so I think it's basically just putting the time on that project and try to do a really good job and try to really understand like why everything works together.
Yeah.
And then that'll come through when you go to the interview and the people ask, "Oh, you did this robot arm project. Well, how does it work? Why'd you do this? Why'd you do that?"
Right.
There's your
There's a
preparation.
lot of interesting things that creep up when you actually use hardware versus doing
Yes.
a lot of things through simulation and software.
Yeah.
I learned that the hard way, actually, the first time I built one of my robots and watched it veer off to the right.
Yeah.
And I was like, but I'm sending the same command to both wheels. And I was
Yeah.
like, this is why people have wheel encoders and things
Everyone
like
learns that the
that.
hard way.
You learn it the hard way.
There's no other way to learn
There's
it.
no other way to learn it.
Yeah.
Right? So I think Yogi Berra says, in theory, practice and theory are the same. In practice, they're different.
Yeah,
Right? So,
yeah, that's
so it's
good.
always one of those things I keep in the back of my mind.
Yeah.
So the next one is from Avishak. Hey Nick, the idea of these origami robots for entertainment purposes for kids is great.
Mm-hmm.
Can these robots be integrated with sensors and a camera so that they can be used for research purposes for testing navigation and planning algorithms?
Yes, definitely. So while I was at Berkeley, I worked on a project for Lockheed Martin where we built like a small version. It was like 5 grams, I want to say.
Mm-hmm.
And it had a little camera on it. It wasn't beaming back video, but it would just take a picture like every 3 seconds or something.
Sure.
And then the laptop that was talking to it would make a decision and tell it what to do. And then also in that same Ron Furian's lab at Berkeley, they've put cameras on similarly sized robots that have legs just like this. And are able to stream video and make decisions based on it. So yeah, definitely.
Awesome.
There's some interesting challenges because it kind of goes up and down, and so the
Camera
video's a little bit
stabilization might be a little
crazy, yeah,
a little tricky.
But I don't know, it just adds to the fun, right?
Yeah, that's the whole point, right?
Yeah.
Get in and start having fun and playing around. So this next one is from K. Shankar. Hi Nick, excellent concept. Coincidentally, just came from the FLL Lego Robotics World Festival in Houston.
Oh, cool.
Robotic design judging. The whole George R. Brown Stadium is full of interesting robotic quote-unquote stuff. Exciting times. 3 questions.
Okay.
Okay, so
I'll
we'll
do
do
my
them
best.
in order.
I'll do
Okay,
my
so
best.
you don't have to remember all 3. What are the most interesting features that differentiate your platform from other robotic toys like Lego?
Oh, I definitely think it's the way that we haven't like run it yet, right? So,
Right. So we should definitely show
I mean,
people what you can do.
Yeah. Let's see.
Take note, Lego.
Yeah. So, I mean, I think it's 2 things. That's fine. We've actually thrown this thing out of an airplane and it survives. We have a great video on YouTube about
really?
it. Yeah, yeah.
So you can actually see there's actually, looks like it lights up a little bit in the front as well.
Yeah, yeah, you can change the eye color. It comes with various sounds and like actions and things. But so I think that the animal motion is one of the big differentiators. And then the other thing is the folding building process.
Right.
I mean, we can see this as like a new type of Lego, essentially a new construction paradigm in toys.
So can you actually swap out the shells on these as
You
well?
can.
So,
Yeah, you can swap out
If
all
you
the
get
shells.
bored one day, you can swap it out to something else.
Right,
That's
right.
really cool.
Yeah.
So his second question
Okay.
is, from an algorithmic platform perspective,
Mhm.
what are your current challenges and pain points?
From an algorithmic platform perspective. Okay. I think from a platform perspective, I'm not sure what he means by algorithmic platform, but from a platform perspective, I think we want to be able to develop a lot of different connected toys very rapidly. I think the hardest part of that is the mechanical hardware and the design. You know, it's really hard to scale. Like, okay, if we need to make 20 different shells, it's really an artist like drawing 20 different shells, right? Whereas the electronics hardware, I think, is replicable and reusable. The app, can be reskinned, whether it's going to be Kamigami Robots or some other brand. And the backend analytics can be applied to everything. So like those parts scale really well, and that's what we refer to as like our connected toy dev platform. The mechanical hardware and the design, it's really hard to scale. So those are some of the challenges there.
Gotcha. Cool. Thank you. His last question is, when you peer into the future, say 3 to 5 years, what interesting topics do you see evolving?
I think there's a few. I think swarm robotics is really interesting.
Me too.
To see what you can do with a lot of units. I mean, these we have down to like $49. If you can bring that down even more, you can start to get to points where people can really buy like multiples of these. I think when we started this in 2013, I was saying like I want to get to the point where we can do like real life StarCraft, where like you have like teams of robots, like
battling
fighting
against each other,
and it's all managed by the mobile device.
I like it.
Yeah,
I definitely
Yeah.
I'm in. Let me know when you get there. I'm in.
Yeah.
So, sorry, he has 4 questions.
Okay.
Here's a follow-up. One more thing. Have you thought of helping special needs kids on the other spectrum companion for elderly and disabled? So have you looked at helping special needs people, or on the other end of the spectrum?
I've actually
like
got
elderly or disabled people.
this question a few times before. So we focus on connected toys. That's what we do. I think there's a lot of things we could do. We've chosen to focus on connected toys. It has been suggested to me that this would be like some all-terrain wheelchair, which I thought was a really interesting, great suggestion, but I think it'd be a little bit rocky ride. So yeah, right now we're just sticking to connected toys.
Gotcha. Perfect. Thank you. So this is Ben. So Ben asks, what's the computer on that little bug, and how do you program it?
Yeah.
So I know we talked a little bit about using the drag and drop interface on your phone.
Yeah.
Right? But I don't think we talked about the board that much.
Right.
Or if we can program it with something else.
So let's see here. So there's the app, of course, where you can like build the games, right? So that's one way. We also do have a somewhat rough like Bluetooth API. So if you want to develop your own app for it, we'll give you basically all the plugin points, right?
Oh, very cool.
Yeah. So you can write an app and you can send a command and it'll make the robot do things. And we just tell you like, oh, send this command and it'll do this, send that command, it'll do that, right? That's the best way. The firmware, I don't think can be modified, I want to say. Yeah.
Okay.
Yeah, it's just from the app level.
Sure. Makes sense.
Yeah.
So next question is actually from Ben from YouTube. So, same question actually. Excuse me. So Biso asks, hi Nick, can you tell us about some of the key softwares that you use as a developer?
I'm not the software developer, so.
Yeah, full disclaimer.
Yeah. Yeah. So I think, as far as, so there's a few pieces of software. There's the firmware, the software that sits on the robot.
Sure.
The development environment is Kyle, and I think it's done in like embedded C.
Okay.
The apps are coded natively right now. Also toying around with maybe cross-platform or Unity. But otherwise, yeah, the iOS we do in, I think it's Objective-C, right? And then the Android is Java.
Right.
And then the back-end analytics, we're using mostly managed services for that, like Amazon and Google Cloud type stuff.
Cool.
Yeah.
Let's see here. Looks like we have a question from Sunyanja. Would you consider making them smaller, having a swarm of those, and use them for search and rescue mapping applications?
Yeah, so
it sounds like this is kind of where you got your start, basically.
Yeah, that
right?
was definitely where we got our start. The motivation was always like, if there's an earthquake, if there's a building that's like in rubble, then you can send robots like this into the building.
Right.
And what's cool about it is because they're so small and so inexpensive, you can send like thousands in, and you only need a few to succeed, right? You put a CO2 sensor on it, it finds a person. So it's like a distributed system, which is great. So yeah, definitely search and rescue applications. And then as far as making it smaller, yeah, I think that would be pretty cool. Again, this construction lends itself to being really small, so we can definitely shrink it. The challenge there is mostly in the actuators. So these motors are like 6mm diameter DC motors. They're still not bad at 4mm, which is a pretty big difference.
Sure.
And so you can definitely make it, I don't know, maybe 2/3 or half size. Beyond that, it starts to get really tough for actuators. When we had that really small 5-gram robot, it used shape memory alloy, which is extremely small. It's basically a thin wire that when you put heat through it, it contracts. But it was so slow. Like the cycle time is like 1 hertz, like 1 per second.
Sure.
So it moved like 1 millimeter per second. Pretty boring toy.
Yeah.
Yeah. Yeah.
I don't think that would last more than 2 weeks
Yeah,
with any child. So 2 hours might be a stretch.
Yeah.
Have you looked at things, so this is kind of a question for me actually, I'm just kind of curious,
Yeah.
have you looked into like soft robotics and things like that? I mean, obviously your platform kind of bends, but if we're talking from like a search and rescue perspective, right? Having something that has, softer joints in it, not so much, big metallic pieces to kind of bend around corners.
Yeah, this is, kind of a type of soft robotics. It definitely bends and flexes and will survive. But as far as what I've seen with other robots that, do pneumatic or hydraulic
Right.
and are like
Yeah.
really soft. We haven't done anything like that.
Yeah.
Yeah, we haven't tried that.
I know it's really kind of early stages for those things.
Yeah.
They're just starting to kind of break into the market a little bit.
Yeah, and that's one where I think it's a whole systems problem with materials and actuators and
Right.
all that to get right.
Yeah, definitely. Yeah, it's very challenging.
Yeah.
And those move very slow from the ones I've seen.
Yeah.
So
yeah.
100 times speed, they're still kind of slow,
Right.
unfortunately.
Right.
It's a great technology. So Mo Jami asks, Nick, my grad project is flight motion simulator using Stewart platform. What advice would you give us? So I don't know if you have any.
For what?
For any-
I don't know the specifics of the question,
Yeah.
but I would just say again, like, do projects and be able to explain them inside and out would be the best thing.
Yeah, test.
Yeah.
Right there.
Yeah.
So Chris asks, what is the proportion of additive MFG versus subtractive MFG? So 3D printing versus traditional MFG.
So actually, in our first generation, we 3D printed all the gearboxes. So these are injection molded gearboxes.
Okay.
But the first generation, we did about 1,300 units, and then we 3D printed all of them. So that was all additive. Maybe you could count the PCBA, the assembly of the electronics, as additive because you add the pieces on. But for the most part, it's subtractive. So just to go through how it's manufactured, this piece is laser cut, which would be subtractive. This piece is stamped, which would also be subtractive. This is PCBA. This is a very standard process with a pick and place machine. These pieces are injection molded,
Okay.
which I guess you could call additive, but it's not 3D printing or anything like that. And the gears are also 3D printed. And that's the whole thing. These we buy.
Nice.
Yeah, but they're ultimately injection molded.
So, okay, Soundcar is back.
Okay.
He's got another question.
Okay.
Are you thinking about a quadcopter platform as well? We could use them to build a quote-unquote Jarvis.
That's interesting. So I think for this product line, like there's a motif of bio-inspired, and so we've thought about doing like a flapping wing
Right.
robot, which would be pretty fun. But I could definitely see that for another connected toy
Sure.
product line. Yeah. A few people have tried it. I don't think anyone's really nailed it yet. So yeah, I think there's.
I think it'd be really cool with your materials too, being that they're so rugged. Right?
Yeah.
I mean, you wouldn't really have to worry about crashing and being out.
Yeah. That's a good
$1,000
point,
like
actually.
a DJI drone or something
Right.
like that, right? So
yeah, that would be cool.
So good idea.
Yeah.
So okay, I think that's pretty much it for today.
Okay.
Nick, I'd like to thank you again for your time.
Yeah.
If you want to say the name of your company one more time and where they can reach you in case they have any questions,
Yeah.
feel free.
Yeah, the company is Dash Robotics. The product is Kamigami Robots. I'm Nick Kohut. My email is nick@dashrobotics.com. So please check us out. If you want to be a mechatronics engineer, Android developer, robotics person, yeah.
And if you want to get started in robotics, make sure that you register at udacityrobotics.com or robotics.udacity.com for our Slack community. And make sure to check out udacity.com to see all of our great nanodegree offerings. Okay, thank you very much.
Thanks.